This is the ellipse. Okay. An ellipse is a collection of points in the plane, the sum of whose distances from two fixed points called the foci is a constant. You can draw an ellipse by taking two push pins and cardboard with a piece of string attached as shown. The place where each pin is the focus, the plural of which is foci. The sum of the distances from the ellipse to these points stays the same because it is the length of the string. Parts of an ellipse: you have your center, major axis. It's in the direction of the longest part of the ellipse. You have your minor axis, your foci, and on the ends of the major axis are your vertices, which are part of the ellipse. The equation for an ellipse can be derived by using the definition, and the distance formula of the equation is given here: x squared over a squared plus y squared over b squared equal to 1, where a is greater than b, greater than 0, and b squared is equal to a squared minus c squared. The values of a, b, and c tell us about the size of our ellipse. Okay, so in this case here, a is larger, so it's spread out over the x-axis there. Okay, there's a major axis there. There's our A, and there's our B, and C is found here, all along the major axis. On the vertices and the foci, and graph the ellipse. So in this case, the major axis is going to spread out over the x. We have 3 squared here, so A is 3. At the very ends are the vertices. Here 3, 0, and negative 3, 0. And at the center there. From the center along the ends of the minor axis are b in each direction. So you're going to have b square root of 4, which is 2. Now you can draw your ellipse. Okay. Foci. They are c away from the center in each direction along the major axis. C squared is equal to a squared minus b squared. 9 minus 4 is 5. So square root of c is equal to square root of 5. And there's the location along the major axis. The center of the ellipse can be transformed from the origin. The equation would then be, in this case here, a is larger, so spread out along somewhere on the x-axis. And next one here, in this case here, a is larger and is spread out over the y-axis somewhere in the y direction. If an ellipse is not in standard form, you must do so to get it looking like that. The right-hand side must always be equal to 1. So an ellipse can have a vertical major axis. In that case, the a squared is under the y squared. Like that. You can always tell which value is a because a squared is always greater than b squared. Find the equation of the ellipse here. So we have our vertices there at the ends of the major axis. So in this case here, 4 and 4. So 4 squared. For the minor axis, it goes over 1 squared. So you know the major and the minor axis. You know our A and our B, we can find the C. C squared is equal to a squared minus b squared. minus 1 is 15. And it spreads out along on the y here, the major axis. Find the center, foci, vertices, and graph the ellipse. In this case, we have to complete the square. So we collect our x terms and our y terms. We factor out to make the x squared, the coefficient for the x squared and y squared 1. So I factor out a 4 and a 3 respectively. To complete the square, I take the x term here, take half of it, the coefficient, and square it and add it. Half of 2 is 1, so add a 1 here. Half of a negative 2 is a negative 1 squared, and add a 1 here, and add a 1 and a 1 there. Notice it's 4 times that, because I had to factor out a 4, and it's 3 times that. So I'll put that here. And that's how that looks. Simplify it, put it in the factored form. So for it to be in standard form, we have to divide by 12. So I divide both sides by 12. And there we have the equation in standard form. Now we can find information from and graph it. In this case here, looking at it, you can see where our center is going to be, negative 1 and 1. Our major axis, A is large, so that's our A. A is 2. Okay, so we have our center, so we can go up 2 and down 2. Up 2 and down 2. On the minor axis here. So square root of 3 is square root of 3 here for our B. So we can go up, over, to the left, and to the right one. Okay. And it gives us a little shape for our ellipse. So we have our A and our B, and we can find our C here. C squared is equal to A squared minus B squared, which is 1. C is 1 spread out over the major axis. So going up 1. Going down 1. So that's where our foci are. Any applications of an ellipse in the solar system: elliptical orbits, elliptical bicycle, and in architecture here. They have a whispering gallery where a person stands at one end and whispers on one foci, and the other one stands on the other focus. And you can whisper, and it'll bounce in such a direction they can hear what they're whispering. Also, in Roman days, they would use a parabolic nature to design the theaters. So a person could stand in one room, in one spot, at the focus, and everyone could hear them. And that finishes that.